Okay, so hello everyone. Today we'll be doing the LeetCode 496, which is next great element 1. So this is one of the starting problems of a major pattern, which is monotonic stack. Many problems are based on this from the stack part. Graded temperature and the next great element 2 and much more problems are based on this pattern only. So we'll be mastering this here, then they will be much easier for you to do it. Okay, so first we'll understand the problem, what it is. So we will be given two arrays, what is nums1, one is nums2, and nums1 is basically a set of nums2. As we can see, 4 1 2 is also present in nums2. What we have to exactly do is, see, here it is 4 in nums1. So first we have to find where it is in nums2. Here it is at the 2 index. Now we have to find the next greater element in nums2 to it. 4's next element is 2, but it is not greater, so it will store -1. Same as for 1 in nums1, we will find here it is nums1. In nums2 here it is 1. We will find it has 3 4 2 as the next elements, but next greater element is 3, the immediate next greater. We will store 3 here, and for 2 is the last element, so it does not have a next element, so it will store -1. So now we'll be moving forward to the brute force approach of it, and then we will move to the optimal approach of it. So we'll start by doing the brute force. So okay, whenever you solve a DSA problem, always think about the simplest solution first. Don't jump directly to the optimal approach. It's the basic manner, you can say, to solve the DSA problems. So okay, now think of it as, okay, so for every element in nums1, first we'll find where that element exists in num2. So once we know its position, simply keep moving towards right, and the moment we find a greater element, stop searching. This is the basic brute force approach that we can think of, right? So we will have to also store the answer somewhere, so we can use a different data structure for it. So yes, this was the basic approach. So how we will visualize it? So yes, this is the starting point. For nums1 is 4, so first we will find where it is in the nums2. So here it is at the second index. So this will be an outer loop, and this will be doing an inner loop. So if we find 4, then we will be using another inner loop. It will not be a nested loop, but it will be another inner loop that we will start from here, from 2 to last, but here it is 2 only. So we'll try to find whether there is a greater element than 4 or not. Okay, so okay, let's visualize it. It will be easier for you. So first loop would be I is equals to 0. This is on nums1. Okay, 2, we can say nums1 dot size. So this is only a pseudocode, so don't go on to the syntax part. So yes, this is in the nums1. So this will be the outer loop, and in the outer loop we will be storing nothing as of now. So what we will do is basically, okay, so we'll be running an inner loop also. J is equals to 0 to, we can say, nums2 dot size. Okay, so what we are doing in the inner loop, so if we can say I is equals to 0 is 4, so we will be finding where is 4, right? So whenever we can say we can say nums2 of j is equal to nums1 of I. What this means, that 4 is equal to 4. 4 finds its brother in nums2. So whenever this condition happens, we can store its index for future use. We can store it in an index variable, the j. Okay, where will we find in the nums2? So j is the nums2 variable, the iterative variable. So we'll store it in index variable. Then in the I is equals to 0 inner loop only, this is not a nested loop, it is another loop in I is equals to in nums1 loop. Okay, so this will start from basically index plus 1, because we will start from the right of 4, right? We can take an example of 1 also. Like for 1, we can say for 1 will start like the right part, no? So index plus 1, we can start from 3. We will find from 3 to nums2 dot size, of course. So yes, now what we will do is, okay, and before this we can also declare a boolean variable. I will, like, not boolean but a dummy variable. I will tell you why we are doing this. So basically what we have to do is, if we will not find any of the, like the greater element, so what will we have to store in the answer vector? We'll have to store -1. So the default value would be -1. Okay, so we will store -1. Okay, so basically, okay, so yep, but if in the loop we find, if at any point the nums2 of j, we can say, is we can say yep, nums2 of j is greater than the nums1 of I, nums1 of I is 4, no? So if at any point nums2 of j exceeds this value, then we can store in greater element. What we can store is, we can store nums2 of j. Okay, and at the last, what we can do is, in the answer vector or an array or anything else, we can take it as vector. So we will push back it in the answer vector. Okay, so here it comes in handy, because for 4 if we take, then it will not find any of the greater element. So what if it has to store? It will have to store -1, right? So if it has to store -1, it will be storing like a -1. So it will give -1 here. But if we find a greater element, like for 1 we got here 3, so then it will store from this condition, like we got this condition, and the greater element will be updated as the nums2 of j, which is 3. So it will store this. So this was the brute approach basically. So now we'll be moving forward to the optimal approach just now. Okay, so now we'll be moving forward to the optimal approach of this question, the next data element 1. So here it comes like the main idea, which is the monotonic stack. So how, like, okay, so imagine it as, like, in the brute approach, what we were doing is, we were finding for each element with 2 loops, like it was nested loops, 2 nested loops, but okay, so not 2 nested loops, 1 nested loop, and in the nested part there were 2 loops. Okay, so it was basically O of n square complexity, because there were 2 loops, like 1 nested loop, so it was O of n square. Okay, so imagine for every element, like for every element in nums2, what if anyone tells you from before only that these are the next data elements for all the nums2 values? Then it will be very easy to find all the answers in the nums1, like if anyone tells you from, like they give you data which tells you, like for 1 the next data element is 3, for 4 there is no one, so -1, and for 3 this is 4. It will be very easy for us. Okay, so this is the intuition. For this we will be having an hash map and an ordered map that will be storing all the values, and how we will be finding those values is through a stack. So we will be moving from right to left. Basically we will start from 2 to 1. And why right to left? Because the next greater element always right on the right, no? So if we stand on an element, everything on its right has already been processed, so that means our stack already contains all useful candidates. Okay, you will understand why I are doing it from right to left. So starting from 2, so we'll start from the last element. The stack is empty, there is no greater element. Okay, if the stack is empty, so yes, 2 has no next element, so it will be storing in the hash map as -1 as its value. It's the key value pair in the hash map. Now we'll be pushing 2 here. Okay, so now the next current element is 4, right? Now we are at 4, so top is 2, so 2 is smaller than 4, so it is of no use, of course. So yes, we will remove it, it is of no use, and we will push 4 here. And for 4 we did not find any useful value, so yes, it also contains -1 because it does not have a greater element in right. So now we will have current on 3, current pointer on 3, and the top is 4. So 4 is greater than 3. Yes, it is a useful value. So 3 will be storing as its value 4. Okay, we will not pop 4 because it's a useful value still. Now we will push 3 also, because we have to find like the immediate next greater element. So yes, top should be the the latest greater element, So yes, the current will be at 1 now, and 1 will be having this 3 is greater than 1. So yes, 1 will be having 3 as its value. Key value pairs are these, So this is our hash map, and we'll be pushing 1. It is of no use now, but yes, we will be pushing 1. This was the main idea. And now if we will go and run a loop on nums1, and we for 4 we have a value here -1, we'll be storing -1 in the answer. For 1 we are having a value of 3, so we'll be storing 3. For 2 we are having value -1, so we'll be storing -1. So this was the main idea. So now we will try to code it. Okay, so what was the main intuition? We will use 3 different type of data structures. So one would be an unordered map, okay, which will be having key value pairs at integers data type. Then we will be having a stack, of course. The stack would be containing all the main data, the useful values, and then we will be having an answer array, of course, because we have to return a vector here, a vector. So these 3 data sets we will be using. So yes, first of all, we will be processing nums2 from right to left. So what we will do from processing it from right to left will be nums2.size, and I hope you do not have problem in understanding the syntax and all. I am guessing that you know all the basic syntax of C++. So we will be moving from the last nums2 size -1 to the front, which will be greater than equal to 0, and we'll decrement the value. Okay, so now, so first of all, if we have in the stack, if the stack is not empty and the right elements are smaller than the value, if we had you can say if we see at the whiteboard, for 4 we did not have a greater element in the right side, no, in the stack. So if we have like this, then we will pop the values. Okay, so if we come back to the code, so while we can say the stack is not empty, it should not be empty, because if it is empty we will have to push some value. If it is not empty and the stack top is basically, you can say it is less than equal to nums2 of I. Okay, so what we will do is we will pop the value because it is of no use. Yup, and we will store -1 for them. We did it like this only, no? So if if we pop it, it will be empty, of course. So if it is empty, if the stack is empty, okay, then what we will do in the map that we have created, we will store the nums2I as -1 because we do not have a greater element for it, right? And in the next we will store the real greater elements. So if stack is empty, okay, my bad, we have written. So now we will store the real part, if the conditions are normal, it is not empty and the stack top is not less than also. And yes, so in that case what we will do is the map of nums2 I will store what it will store, the stack top, because it will be greater, of course, right? For 1 we got 3, and for 1 we got 3, and for 3 we got 4, okay, in the whiteboard, as we can see. So now in the code we will have here, now we have the the map ready, and of course if we are doing it, we will push every value to the stack, then only we can have something to compare, right? So nums2 of I will be always be pushed, okay, we will always have value in the stack, whether the case is okay. So now we will store the final values from the map. We will find Okay, so we will run this on the nums1. So we have all the data, as we said in the starting. We have all the data, and we can push back in the answer. And what we can push back is from the map we can take the final values. We can take num, the key, and it will push back the value of the key which is in the nums1. It will store it in the answer, and then in the final we can return the answer. Okay, so if we run it, it can give us the right answers. It will pass. Okay, so here is just a second. Okay, a curly bracket is missing, my bad. So yes, if we run this now, it will run correctly, right? Yep. Okay, so it is the optimal approach. So if we talk about the time complexity, the time complexity of this is like every element is entering the stack once and it is exiting the stack once. So it is basically the max would be like 2 into n. Okay, the max complexity will be 2 into n. So yes, of n is the time complexity, and this space complexity is also of n. And if we talk about the brute force approach, so it would be having, like, we had one nested loop. So yes, of n square would be for it, like two loops. So yes, of n for each, and if we have nested, so yes, of n square would be for brute force, and for this it will be having of n. So this was all for today. So this was the basic idea of monotonic stack, and this will help you in the next greater, next smaller, previous greater, previous smaller. So this will be done by monotonic stack only. So please like the video, subscribe to the channel, and yep, that's all for today. I'll see you in the next one. Thank you so much.